radical equations. Okay, we are going to be using these skills that we've been working on to help us do that. And I need to show this too. Okay, so how do we go from radical form to exponent form, radical notation to exponent notation? So I have the fourth root of 13 cubed. So that's going to be 13 to some power. The index of the radical is the denominator of my power. So that fourth root is a 1/4 power, and then that power, the exponent, becomes the numerator of my power. So the fourth root of 13 cubed is equal to 13 to the 3/4 power. Make sure you're not writing it as 13 3/4. Okay, that's not okay. It needs to be an exponent. Going the other way around, right? What if it's in exponent notation and I want it to rewrite it as a radical? So -7 to the 1/5 power. Well, I know it's going to be a radical, so I'm going to start there. So this radical over -7. I like to look at my denominator first because that tells me my index. So that would be a 5th root. Okay? And then the numerator is my exponent. So I've talked to you guys about there's 2 ways to do this. So we could put a 1 there, and of course we don't need a 1 there. Or we could do it this way, and this really would be the way I would prefer you guys do it. I already talked to you guys about how it was helpful before, and again, it's interesting. You guys still there? I feel like I'm dead. Huh. My computer's doing something weird. All right, whatever. Yeah. So again, I think this way will be much better for you guys to write it this way with the parentheses than the other way. Okay, and I'll point this out later, but I'll let you know. All right. So using your roots chart, what's the cube root of 512? Right, Jarrett. Right, Kyle. 8. Using your roots chart, what's the fourth root of 625? Right, Jarrett. 5. And then how do we use our roots chart to figure 16 to the 3/4 out? And some of you guys just did on the quiz. Right. First thing you do is translate that into a radical. So that's the root of 16. And our denominator is our index. So that's the 4th root. And the exponent is from the numerator. So this is the 4th root of 16 cubed. Yeah, we don't call it the quadratic root. Aiden's just the 4th root. I gotcha. So what is the 4th root of 16? What's that equal to? Yep, 2. So we got 2 cubed, and 2 times 2 times 2 is what? Right, Kyle? 8. So using your chart, we can evaluate powers with rational exponents. Okay. So those are all skills we worked on before. We're just bringing them back because we're going to use them again here today. There are going to be 2 basic types of equations we're going to look at. So here we have the ones with radicals in them, and then we're going to look at ones with rational exponents in them. We know that rational exponents are just another way of writing radicals. So they're very, very similar, just they look different. Okay, those are the 2 really basic types of equations. And you guys, the video that some of you watched on Tuesday and the short problems that some of you did on Tuesday, not near enough of you did on Tuesday, on your assignment was relating more to what we were doing tomorrow. It's gonna be a higher level problem than what we're doing today, but definitely things that we saw there are going to be important. And way too many of you gave me answers that looked exactly like the photo math version of doing that problem. I'm not too happy about that. So I'd rather see what you can do, and then even if you can't do it all the way and know where you're having issues, than to see what photo math can tell you how to do. So, and I don't even like the way PhotoMath does it. So some of you guys that turned that in, I was writing some junk on yours, things that you shouldn't be doing. So, I really don't want to see that. It's kind of pointless. So, so isolate the radicals, our first step. Okay, raise each side to the same power as the index of the radical. Simplify and solve and check our answers. Okay? I'm talking to you guys about how to check your answers. But this first step, isolate the radical. What does that mean? So when it says isolate the radical, this is the radical. This is the radical. We want that stuff that's outside of it to go away first. Really, guys, if you focus on something I've been talking about all year, which is just SADMAP, you'll be fine. How do we solve equations? We undo them. What order do I undo them in? Well, we undo them in the opposite order of PEMDAS. Okay? So when it says isolate the radical, that's because the radical is an exponent. So I need all that stuff that's on the outside of it to go away first. That 9 needs to get gone. That 2 needs to get gone. That 7 needs to get gone. Okay, before I can deal with this. Okay? So if we just think there, instead of having to memorize steps, it's just something we've seen over and over again. How do I solve this equation? Okay? So I look on the outside of the radicals for any subtraction addition first. Well, lo and behold, there's some subtraction. Well, how do I get rid of subtraction? I add. So if I add 9 to both sides, that gives me the cube root of x equals 8. So our radical is isolated. There's nothing else around it now. Okay. Well, how do I get rid of a cube root? We raise each side to the same power as the index. Oh, so we better know what an index is, right? So here's our index. This is a cube root, so we will cube both sides. This is a third root, so we will raise both sides to the third power. Okay, do you hear these similarities in the language? Cube root, cube both sides. Third root, raise both sides to the third power. So, cube that, cube that. Why am I doing that? Well, the same reason I added 9 to cancel that 9, right? We do this to cancel something on one side. Well, that 3 is going to cancel that third root. And so what am I left with there but x? So then what is 8 cubed? So you can use your chart to tell you what 8 cubed is, or you can use your calculator to tell you what 8 cubed is. All right, 512, right, Kyla? Not cube root, Jarrett. 8 cubed. Got me? Easy mistake to make. Okay, so there's our answer, right? We think. So we check that. So when we talked about the checks on Tuesday, what do we do with this 512? Where do we put it? When we check an answer, where do we check it?
In with the x.
What x? There's lots of x's here.
In the original problem.
There you go. In the original problem. Okay, you always use the original equation when you're checking. That's the equation we're supposed to be solving, so it better work for that problem. Okay, so we always use the original equation. So the cube root, 512 minus 9, is supposed to be -1. And so that's where we do it, and then how do we do it? Okay, you simplify only, and this is again something I've talked to you guys about before. Simplify only. Okay, and by that I mean you do not ever move anything across the equal sign when you're checking. You do not solve. You simplify. Okay? As you're checking, you only simplify. That right side better stay -1 the whole way down. You're trying to see, does the left side actually equal -1? That's the question. And do not move anything across. If while you're checking on a quiz and you one step you move something across, your whole check is invalid. Okay? You have to leave it the way it is. Just simplify. Okay? So where do I start, right? And because I'm simplifying, now I should be following PEMDAS. Like, how do I know what math to do first? Okay. Well, I don't have any parentheses, but I have an exponent because a root is a type of exponent. So I need to simplify the cube root of 512. Well, good thing I have a chart for that. What's the cube root of 512? 8, yep. Then 8 minus 9 is -1. What do I do next? There's no multiplication, but there is addition, subtraction. Right? So now I'm simplifying that. And -1 equals -1. Check. Right? So we're good to go. Nothing went across the equal sign. Let's try another one together. I want to isolate that radical. I want to use SADMEP to get that radical by itself. Okay, so I need to look for any subtraction addition to get rid of first. So I want to get rid of that 7. So I got 2 times the square root of 10x equals 16. I want to look for any division multiplication to get rid of next. Okay, so dividing by 2. So the square root of 10x is equal to 8. So our power is isolated. Our radical is isolated. So we're at that point now of how do I get rid of a square root? Okay. Well, what's my index here? What number's right there? Yeah, 2, right? So if my index is 2, I would raise it to the 2 power, right? It's a square root, so I would square both sides. Okay? Let the language talk to you, right? It's a square root, so you need to be squaring. Okay? Why are we doing that? Because a square will cancel a square root, just like a 2 here would cancel that 2, and a 7 here would cancel that 7. Doesn't do anything else, just cancels that, so we're down to 10x, and of course 8 squared is 64. So we've done most of the work, right? And the last step's really simple, right? Just get rid of the 10. No biggie there. Normally I would tell you guys that you should leave your answer as a reduced fraction. I normally ask you guys to do that. I think with this particular type of problem, it becomes kind of a pain to do that. If I notice both of those have a 2 in them, I could write that as 32 over 5. That's really, an answer like that is a pain to check. But it is the answer. So something a little bit simpler here would be just go ahead and do 64 divided by 10. Divided by 10 just moves the decimal, so that would be 6.4. Okay. So kind of a situation where I'd say, let's go ahead and just use the decimal here. It'll be easier in our check. Okay. So there's what we think the answer is. So we go back to that original equation. We're going to check 6.4. So we get 2, 10 times 6.4. All that should be under the radical. That's a 10 there. Minus 7 equals 9. Now again, where do I start? We look under that radical, see what's there to do there, right? We should do this multiplication here first. That'd be 2 times 10 times 64. Just move that decimal again. It'd be 64. And then I want to do the I want to evaluate this. All right, what's the square root of 64? You should just know that. 2 times 8, which would be 16 minus 7, which would be 9. And the right side was equal to 9 the whole time. Right? Nothing went across the equal sign. Right? 9 equals 9. Oops, sorry. So must be good to go there. Anything you guys want to talk about? You ready to do a problem on your own? Jubal, how you doing? Good June, good Jared. Braylon, how you doing? Brian, how you doing? Good Sophia. Okay. All right, why don't you guys try number 3 here? Throw your answer at me in the chat if you want, but again, you guys can always check it, so you should know if it's right or not. Try number 3. All right, so I want to cube both sides to get rid of the cube root. And once we're there, then this should just look like, easy peasy algebra 1 equation. Okay. Jarrett, what went wrong on your end?
Instead of raising the powers first, I added the 4 to the other side.
Yeah, so you gotta be careful, right? Because that's not a 4, it's the cube root of 4.
Yeah.
Right? And so it's a completely different number than 4, so yeah, can't just move it like that. So, okay. All right. Just being careful about that in the future. Anybody else got questions on this one? Braylon, you doing okay? Samantha, you doing okay? All right, last one here. These. So isolate. All right, so we want to look at that power, see that we got a radical 2x here. So let's get rid of that 10 first. So that'll give me the square root of 2x equals -6. Then it's a square root, so we're going to square. Okay. So of course the square is there to get rid of the square root, so that just leaves us with 2x. And -6 times -6 is 36. And we're not quite alone yet, so we want to get rid of that 2. So x is 18. Nothing too crazy going on there. Go back and check. 18 though. We'll just go back to our original equation. So 2 times 18 under the radical plus 10 equals 4. So where do I start my checking process? Underneath the radical. That'd be the square root of 36 plus 10 is 4. Well, square root of 36 is 6. 6 plus 10 is 4. 16 is 4. What the what? All right, so we got our answers doesn't work, right? And it's not true. So one of the things from the video on Tuesday, guys, was understanding did we do something wrong, or was this supposed to happen? Like, was this going to happen no matter what? Right? That difference between being extraneous and being incorrect. How do we tell? Did we do something wrong, or was this unavoidable? Was this an extraneous answer from the get-go? How do we tell? This is one of the questions you guys answered in the homework. What's the difference between an extraneous solution and an incorrect solution?
The difference is that an extraneous solution is something that doesn't work in the original equation, and an incorrect solution is just wrong.
Okay. But how do we know that? Like when we look at it, how do we know this is saying, hey, that's extraneous versus, hey, this is wrong? What is it about our check that tells us that? Yeah, I mean, so what you're saying, Jared's right. And, if Aiden, again, that'd be a wonderful thing to say in the public chat. An extraneous answer, we didn't do anything wrong. It just isn't going to work. Incorrect, we messed something up, right? That's, I mean, definition-wise, but visually, when you look at your check, how do you tell the difference? Hey, how does it say, hey, you did this wrong versus, hey, that's extraneous. You're all good. It just wasn't going to work no matter what. A point they made in the video was that squaring is not what? When you square both sides of an equation, doing that is not what? Yeah, right, Tiana, it's not reversible. Okay, and so when we did this right here, this step, we created a space for something to go wrong. Because negative 6 squared is 36. But when we square root 36, what did we get? We didn't get negative 6, we got 6. So how do you know if it's incorrect versus extraneous? Is if we changed one sign, it would have been fine. If this had instead said negative 6 plus 10, then it would have said 4 equals 4. One sign is all the difference. That's how you can tell that this is extraneous versus wrong. Okay? And what's not so blatantly obvious is that it's not this sign always. It doesn't say 4 equals negative 4. It's one step up. Okay? Where did that square root happen? That's where things can go wrong. Okay? That one sign being off is enough for me to say, okay, that's just extraneous, not wrong. It's really important for you guys to know the difference. Because if you do it wrong, if you wrote the answer was 15, you're just wrong. You messed something up. Okay, and then boom, there's your answer on the test. Well, that wasn't right. You checked it, and you said, well, must be extraneous. No, it's not extraneous. It's wrong. That's what this is trying to tell you. Because it's not just one sign. When you plug in a wrong number here, it won't look at all right. Okay? So it's not going to just be one sign off. Okay? So it's very important for you guys to see that. It's right here where things went bad for us. We squared that, we got 36, and we square root it, we get 6. Okay? It's that right there. So we know this is extraneous, so we label it as such. And because it's our only answer, and our only answer doesn't work, what this really means is that this has no solutions. Okay? If you get 2 answers and one of them doesn't work, then you have 1 answer and an extraneous answer that doesn't work. If you have 1 answer and it doesn't work because it's extraneous, you have no answers. Okay? There's just no answer to this equation. Okay? Anything here on these before we move on to the second type of problem that we're going to do? Thanks, Aiden. Okay. So we're going to be looking at these equations with rational exponents now versus radicals, but rational exponents are very closely related to radicals. Okay, essentially little cousins, half brothers, whatnot. So our first step's slightly different. Now it says isolate the power rather than isolate the radical. So when it says isolate the power, what does that mean? What's it talking about? What's the power? That's a power. This is a power, right? The thing with the exponent on it is the power. Okay, so the 3 doesn't have an exponent on it, so it's not part of the power. The 4 doesn't have an exponent on it, so it's not part of the power. Okay. Then we're going to rewrite that into radical form, right? We were practicing that earlier. How do we move from an exponent to a radical? Okay. And then this third step here, I'm talking to you about why I'm asking you guys to do it this way. Okay, it's very specifically written that way to make you guys do it in that order. Really, I think it's beneficial for you to really pay attention to that. Okay, but in the end, guys, if you just follow SADMEP, you'll be okay. What do I undo first? Okay. Now this is a little bit more clear when we say exponent, that this is an exponent, right? And that 3 needs to go away, right? All of this stuff has an exponent on it. And that 2 is kind of protected there because it's all the way in these parentheses. So that 2 can't be dealt with until those parentheses are gone. It's way back here. So anything that's here needs to happen first. Okay, so it's just that isolating idea. Get that power by itself. And so of course we're going to divide by 3 first here. So I get x to the 2/5 power equals 4. Okay. But it's hard to understand what x to the 2/5 means, so that's why we rewrite it. Okay? What does x to the 2/5 mean? So we know that's going to be a radical. So radical x. Our denominator is our index, so this is a 5th root. And then I very specifically want you guys to write it like this, where that numerator is going to be on the outside of those parentheses. Okay, I mentioned to you that earlier. Okay. There's a very specific reason I'm asking you guys to do it this way. Okay. So there's step 1, there's step 2. We've isolated the radical, we've isolated the power, then we've turned it into a radical. Okay. But there's a lot going on there on that right side, or sorry, the left side, right? You guys haven't seen stuff like this where there's a radical inside and then an exponent on the outside and a variable on the inside. Right? We've done it with numbers. Okay, we understood how to do it if there was a number in there, but now there's a variable in there. What do we do with it? Okay? And the other thought is we're supposed to be getting that variable by itself. So it's not the same as when there's a number in there, because that's just simplifying it down. Now we're trying to peel the stuff away from the variable, right? We want all that variable to be by itself. So I'd like you guys to think about this as like peeling an onion, okay? Because you're gonna cry, all right? That you want to deal with the outside first. Okay, so when you look up at step 3 and it says undo the power first, okay? That square needs to go away first. Well, how do we get rid of a square? How do we get rid of a square? What's the opposite of squaring? Square root it, right, Aiden? Right? It says square, so we're going to square root. If I square root one side, got to square root the other side. Why are we doing that? Because we want that to go away. So those things cancel each other. Okay? So it's really, there's a lot going on here visually. Okay? So you really got to narrow down, focus down. Why did I just do that? What was the point of square rooting? To get rid of this square. And so you can really see what's left, right? You're peeling the onion. This is gone, this is gone. What am I left with? Right here. Okay? So I'm down to this 5th root of x equals, what's the square root of 4? 2. Well, you're half right. What did we just do? We just square rooted both sides. What's that mean? We've done this before, we've talked about this before. We just square rooted both sides. What's minus, guys? When you square root both sides, you have to deal with there's 2 answers to that. Okay? We did that. We square rooted. The square root was already there here. We didn't decide to do that. That was already there. There's a difference. When we square root both sides, we have to deal with the fact that there's two answers to that question. There are two numbers I can square to get 4, 2 and negative 2. Okay. So now we're getting closer to x being by itself. Now we have this fifth root. So we're going to raise both sides to the fifth power. So I get rid of a fifth root with a fifth power. And why am I doing that? Because that's going to cancel that. And then I'm left with my x. Okay? So 2 times 2 times 2 times 2 times 2 times 2 is 32. So this is going to be positive and negative 32. Because 5 positives is a positive, 5 negatives is a negative. So when I do the positive one, I get a positive 32. When I do the negative one, I get negative 32. Okay? So this one has two answers. So we need to check both. Any question here before we do our check on how I got positive and negative 32? Doesn't matter which one you do first. Usually doing the positive one's easier, but okay. Plugging in 32 in, 32 to the 2/5 equals 12. Okay. So you guys actually should be able to do this by hand. Okay. I don't really want you to be burning time calculating this out by hand, because I've taught you guys how to do this 32 to the 2/5. We did it earlier. Okay, but it takes 3 steps just to get this one thing done. I don't really want you guys to waste time doing that. Okay, so I asked you guys to have a calculator out earlier so we can talk about how to do this in your calculator. Okay, so 32 to the 2/5. And why you need a scientific calculator, not just some crummy calculator, is because you have to have parentheses in order for this to work correctly. Okay, so 32 to the 2/5. How do we deal with that? Okay, so if I just type it in 32 caret 2/5. Okay, look up there in the top left, look what it did. It did 32 squared, and then it divided it by 5. Is that what I wanted it to do? No, that's not what I wanted it to do. Okay, whose fault is that? Mine, because I typed it in wrong. Okay, so what should I have done instead? Okay, what do I need the calculator to understand to do? Okay, 32 to the 2/5. Right, the calculator needs to understand that the 2 and the 5 go together in the exponent. The way we tell it that is by putting them in parentheses. And then when I look at what it's telling me it's doing, over on the left side there, right, now it looks like 32 to the 2/5 power. Okay, and look what the answer is, 4. Okay, what I really should have done to really cover my bases is I should have put everything in parentheses. Right, just the way I wrote it. 32 was in parentheses to the, and then knowing that I need to do the 2/5 in parentheses on my own. Okay, because where that starts to matter is with the next answer we're going to check. If I do negative 32, like this, to the 2/5, so I'm like, oh, I remember to put my exponent in parentheses. It's going to tell me negative 4. But it actually shouldn't be that. It's supposed to be this. And see, we actually get a different answer. Okay, so if we really want to cover our bases, we put the base in parentheses and we put the exponent in parentheses to make sure. The positives ones don't matter, but it's kind of one of those things, guys. Do you want to just just do it all the time, and then knowing that doing it when you don't need to doesn't matter, and then but that way you know you are doing it when you do need to, or are you really going to focus on if it looks like this, I have to make sure I put parentheses here, and if it doesn't look like that, then I don't have to worry about it. Okay? It's kind of up to you, okay? Or you're just going to always do it just to be safe. Okay, but 32 to the 2/5 is 4. So I get 3 times 4 is 12. Well, of course, 12 is 12. Okay, so 32 works. We need to check negative 32. So 3 times negative 32 to the 2/5 is 12. We already checked that, right? Negative 32 to the 2/5. As long as I type it in correctly, it comes out to be positive 4. Just think if we hadn't typed it in correctly, if we hadn't put the parentheses around the negative 32, it would have told us negative 4. And then that would say 3 times negative 4 is 12. And we'd think that the answer is extraneous, when it's actually not. Okay? So they both work. It's important that you have a good calculator. It's important that you know how to use your calculator. Having the best tools in the world is useless if you don't know how to use them. Okay? I'm not going to do this one with you. I'm going to do the next one with you guys. And then once you guys leave, I'll go ahead and finish this video with this last example on it if you need it. But it's not anything super special. So I just want to do the last one with you guys because it has a fraction in it. So you guys see that. And you guys have solved problems with fractions before, so it's not a big deal. So I want to isolate that power. Isolate that power. Okay, so we want to get that x by itself, essentially. I'm going to get rid of the 8 first. So watch your handwriting there. 1/4 times x to the 3/4 equals 2. To get rid of the 1/4, I'm going to multiply both sides by 4. That's really what I just wanted to remind you guys of. So we have x to the 3/4 equals 8. Now my power is isolated. That was step 1. Step 2 is to rewrite that as a radical. So what am I going to put around that to finish it? X to the 3/4 is equal to what? Where's the 4 go? Where's the 3 go? Index is 4, 3 goes on the outside. Yep. So index is the 4. And then again, I really want you guys to put it this way. 3 should go on the outside of the parentheses. Okay. And then you're going to take that apart. And the way I was talking to you guys about, we're going to get rid of that 3 first. So to get rid of a cube, we cube root. Again, visually, there's a lot going on there. I get it. Okay, you're cube rooting both sides. So you focus in, why did I do that? Why did I do that? I did that to get rid of that cube. So what's left when I do that? Okay, just the 4th root of x. Okay, and then you look over the other side, cube root of 8 is 2. Did I just square root both sides? Nope. So do I need to worry about the plus minus? Nope. Okay, square rooting's the guy that messes with us. Okay. And how do I get rid of a 4th root? I raise both sides to the 4th power. Cancels here and there, so I'm left with x. 2 times 2 times 2 times 2 is 16. Go back and check it. Again, 16 to the 3/4. So I'd go parentheses 16, close my parentheses, caret, parentheses 3/4, close my parentheses, enter, 8. 16 to 3/4 is equal to 8. I have 1/4 of 8 plus 8, which is 2 plus 8, which is 10, which equals 10. Check, check, check. Okay. This is what I expect to see from you guys as far as your work. Okay, what am I seeing on that left side? What am I seeing in the check? This is what I want to see back from you. Okay. Remember the assignments here on the end of the notes if you need it. It's also in the Google class. Okay, there's a daily point. Okay. Let me know if you need something. We're going to work on stuff like this tomorrow, just on a little bit more complex level. All right. Be good. Be safe.
Thank you. Have a good day, Mr. Baker.
Bye, Tian.
Mr. Baker.
Okay, so looking at that last example, we haven't done yet. So I want to isolate that power. So I notice that the 4 is on the outside of that. So the first thing I want to do is get rid of that 4. So that leaves me with x plus 2 to the 3/2 power equals, it's going to come out to be 512 when we do that. And now that now I've done that, I want to go ahead and rewrite that into radical form. So look at that, x plus 2 to the 3/2. I want to rewrite that as a radical. So that's going to be, I want a radical first. So square root, or just a root here. And then I want to say, well, what type of root am I going to take? So I want to look at that index. So that should go here. And so we would want to put a 2 there, but we don't put a 2 there. That's, when we write a square root, there's not a 2 there. So, I'm just going to kind of draw that arrow that there's a 2 there, but we're not going to write it. Okay. And then on the outside of that's where our index should be. Right. So, or not our index, sorry, our power should be. So we have the square root of x plus 2 cubed equals 512. So I really like that analogy, peel that onion, right? Deal with that outside layer first. So I want to go ahead and take the cube root of both sides in order to get rid of that cube power. And why am I doing that? Because I want that cube root to cancel that cube and leave me with just the square root of x plus 2. Yeah, so really trying to see how that outer layer has been peeled off. Those parentheses can drop away because there's nothing on the outside of them anymore. Then we go over to our chart and we say, well, what is the cube root of 512? We see that it's equal to 8. And since we're taking a cube root there, we don't need to worry about the plus minus, right? It's not a square root, it's a cube root. Okay? And so then square root of x plus 2 is equal to 8. We need to get rid of that square root. We get rid of square roots by squaring both sides. So again, the purpose of that is to cancel the square root, so that's gone. We're down to x plus 2. And then 8 times 8 is 64. And we're pretty much done here. Just need to get rid of the 2. And so x must be 62. So now that we think we have our answer, we're going to go ahead and check that. I'm going to go back to my original equation. 4 times 62 plus 2 all to the 3/2 power equals 2048. And I'm going to simplify that for our left side. So in there I need to do that 6 plus 62. 2 plus 62 first. That gives me 4. That's 64, of course. 3/2 power. Then I want to evaluate this. Again, we could work that out by hand, or we could use a calculator real quick. 64 to the 3/2 power. So parentheses 64, close my parentheses, caret, parentheses 3 divided by 2. So make sure those parentheses there on that 3 divided by 2 especially says 512. Look over there on that left side and make sure that actually looks right. 64 to the 3/2 power. 512. So I got 4 times 512, 2048. Well, 4 times 500 is 2,000. 4 times 12 is 48. I got 2,048. Check, check, check. 62 works. Okay, so it's solving an equation with a rational exponent. And here's your assignment. If you don't have that, it's in the Google class also. Let me know if you need help. See you.